And I'd like to welcome everyone. My name is Rebecca Lowe. I'm the Adult Program Coordinator at the Lewis Public Library, and thank you for joining us this evening. Welcome to our series, Science and Society, Making Sense of the World Around Us. This lecture series is co-organized and moderated by Fred Dilla and Linda Dilla, both of whom could not be with us today, but they are our partners in this, and also by Colin Norman, the former news editor at Science, who is here with us. So with that, I would like to turn this over to Colin. So Colin, the floor is yours.
Thank you, Rebecca, and welcome everybody. I'm delighted to introduce my old friend and former colleague, Jon Cohen. We worked together at Science for more than 20 years, and I came to know Jon as one of the absolute best reporters there are. He's covered infectious diseases for much of his life. And some of you may remember Jon gave a talk to this group about 4 years ago, I think it was, on Operation Warp Speed, the race to develop a vaccine for COVID. Tonight, he's going to be talking about his brand new book. As Rebecca said, it's actually published today. It's called Planning Miracles, How to Prevent Future Pandemics. Jon has literally gone around the world researching this book. He's been to Africa, covering, among other infectious diseases, Ebola and Mpox, to Southeast Asia, looking at the bat colonies there that are reservoirs for all sorts of diseases, including probably COVID. He went to the Amazon to look into insect-borne diseases, and even went to a poultry farm in California. He's also went to just about every major infectious research disease lab in Europe, America, and Asia. He knows everybody. He knows the field extremely well, and he's going to spend about 40 minutes putting all of this into his talk. So, Jon, it's all yours.
Colin, that's very kind of you. Thank you. Colin is one of the best editors I've ever worked with, and I miss him dearly. It's a pleasure working with you for all those years, Colin. I'm going to share my screen to pull up the PowerPoint, so give me just a second to load that.
One thing I should have said is please put your questions in the chat function, and I'll do my best to relay them to Jon at the end of his talk. Thanks.
So you can see the PowerPoint now? It's okay?
Yep.
Yeah. So I opened the book with an epigram from Daniel Defoe, who wrote the Journal of the Plague Year in 1722. And he writes about that after the plague had passed, the common temper of mankind was to forget the deliverance. And that's exactly what has happened with us. We go through cycles of panic and neglect with every pandemic, plague, epidemic, and we have entered the neglect phase now with COVID. But my book is looking at also how we deal with risk versus benefit. And humans just aren't very good at understanding risks and benefits. You know, why do we have a law that says you have to wear a seatbelt? It obviously works. And why don't people wear seatbelts in the back seat so frequently? When we know that if you get in an accident, today you're safer in the front seat with the protections that exist than you are in the back seat without a seatbelt. But our senses of risk and benefit as humans are just really screwy. And that's part of what the book is about, is how bad we are at gauging what the risks are and what the benefits are of different interventions. And we see that writ large now with vaccines and RFK Jr. In 1730, Philadelphia had a horrible fire, burned the wharf down. And Benjamin Franklin had recently moved there. And he published the Pennsylvania Gazette. And he wrote a newspaper article about the fire itself. And then a few years later, he published a letter to the editor that he wrote under a pseudonym, as he often did. He had all these fake names. And in that, he wrote the famous phrase that an ounce of prevention is worth a pound of cure. And he was arguing about having fire stations and having crews at the ready for fires and having buckets and having what were called engines, but basically pumps to pump water. And then he became a volunteer fireman. So I start the book by just pointing out that in 1900, we had the first evidence that viruses cause disease. Because I think it's kind of remarkable that we didn't even know until 1900 with certainty that viruses made people sick. And this was proven in Cuba by the US Army and Walter Reed in this house, where they proved that yellow fever was not transmitted by dirty linens or dirty clothes. And they had people live in the house that had no windows wearing the clothes that were soiled from people who had died from yellow fever to prove this. And then they eventually did prove that it was mosquitoes because they put it on people. But that's how long we've known that viruses are a threat to us. And in 1955, there was a remarkable result from a very large vaccine trial of the Salk polio vaccine that was financed and run by the March of Dimes. And Basil O'Connor, who was FDR's former law partner, ran the March of Dimes. And in the annual report, he wrote that this was a planned miracle. And that's where the title of the book comes from. We have the power with science to plan what appear to be miraculous things. And that polio vaccine has eliminated the disease from most of the world. And there are very few cases today. And there's a push to eradicate it, just as we did with smallpox and the smallpox vaccine. So I open the book by looking at the threats. What are the most prominent threats to us? And the path to probably 70% of the outbreaks that we have are occurring from animals passing on their viruses to us. And the ways this happened, I go into great detail about poultry farming. You can see this is the chicken farm in San Diego Colin mentioned. That's a pretty good way to incubate a virus, living on top of each other like that. And humans working with the chickens are extremely vulnerable. We know that bats can transmit. We know that wet markets, and this is a Cambodian wet market, and poultry there can transmit. We know that exotic animals like eating porcupines is one way to get sick with exotic viruses. And rats and rodents are really good at transmitting. We also know that mosquitoes are really good at being vectors, moving viruses from one animal species into us. And one thing that we don't pay much attention to, that I do in the book, is the role of hog shows in the United States. More Americans go to the county fair and the state fair than go to all sporting events combined. And hog shows present a real risk of transmitting, in particular, influenza viruses, which they do every year to humans. One thing that's heartening is that there really are a limited number of viral families that harm people. Out of all the viral families that exist, only about 25 make us sick. And so one of the focuses of researchers who are concerned about pandemic preparedness is let's pick our targets. Let's focus on these 25 viral families. And some groups even narrow it down to 13 that are the most threatening. So vaccines come in all different flavors. And I think we've been sort of misled by COVID to think that mRNA is better or mRNA is worse. In either direction, I think we're misled. These are all different platforms. All of them work. All of them have risks and benefits. And there are a couple more that I don't even list here. I'm agnostic about the platform. I don't care whether it's mRNA or a recombinant protein or a viral-like particle or an old-fashioned live attenuated virus or an old-fashioned killed virus or a viral vector or DNA as a platform. What matters is how effective are they and how safe are they? That's all that matters. And none of us, I think, really paid any attention to platforms until the mRNA vaccines. If you have children, you probably didn't say to your physician, that MMR vaccine, what platform is it? You didn't care. It was an approved, safe, effective product. And that's all that really matters. Each platform has benefits. They are interesting to tinker with to try to get the most out of vaccines. And cutting edge researchers are exploiting the different platforms to try to get the most, the strongest, most breadth of an immune response out of them, causing the least amount of harm. So one of the great opportunities we have right now, and I call them the dream vaccines, is to make vaccines that work against entire families of viruses or subsets. So in the bottom corner, you can see the coronaviruses that affect humans that are alpha or beta. Well, there are also some that are just SARS related. So SARS-CoV-2 is what caused COVID. SARS-CoV is what caused SARS. So groups of researchers are trying to make vaccines just against what are called sarbecoviruses, which are one branch of that family tree that affect humans. You could make a coronavirus vaccine that covered all beta coronaviruses, or you could be more ambitious and try to make one that covers all alpha and beta, which are the two main branches of the family that affect humans. You could go even bigger and make one that goes after all alpha, beta, gamma, and delta. And these ideas of a universal vaccine are moving forward at a good clip, and people are doing it in really creative ways. One way is there are two illustrations here that show a bunch of different pieces, kind of like on a Ferris wheel. And those are all representative of like different beta coronaviruses. Or you can make one that's just all the different sarbecoviruses, merging SARS, pieces of the SARS virus, SARS-CoV, and SARS-CoV-2 to make something. It can be held together by a ferritin molecule, like an iron molecule can be at the center that holds all these pieces together. There's another way to go about making a universal vaccine that's really clever, and that's to look at a family of viruses and look for the conserved regions on the proteins of the viruses. Parts of viruses mutate a lot and change, and that creates Omicron and Delta and all the variants we've become familiar with. But other parts of SARS-CoV-2 and other viruses don't change. The virus cannot keep replicating if you change those conserved regions. So the bottom there has an influenza virus, and it shows in the yellow that its stalk, it's got a head and a stalk, its stalk doesn't change. So people are trying to make influenza pan-universal vaccines that just have the stalk conserved proteins. People are also making chimeric viruses for influenza that take the stalk and pieces of the head to stabilize it for reasons I get into in the book. But these are all very creative ideas, and many of them are having significant progress in animal experiments. I'm confident that with funding and with the appropriate research, these can move forward and offer us much broader protection than we have today for many diseases. And another push is to buy time. Let's do things faster. The Formula One pit crew went from about 45 seconds in 1955 to about 2.5 seconds today. Well, how did they do that? Well, look at the team on the car. They have several people doing everything in a coordinated way, with one person who's the conductor of the orchestra, and they shaved off all that time. So there are a bunch of efforts now to ask, how can we shave off time? Operation Warp Speed did something many people didn't think could happen. That was go from discovery of the virus to the vaccine in 11 months' time, proving that it worked. Can we go faster than that? Operation Warp Speed was not fast enough. And so now there's a push to, within 100 days, have a prototype vaccine in people and proven within 200 or even shorter. There's another idea that could speed up time, and that's just by making a vaccine that works against a family of viruses, but isn't great. It will buy us time to keep people from dying because it will give us some immunity. It's not the ideal vaccine, but what if we had, for the 25 families of viruses that harm us, what if we have one vaccine for each of those that did something? It would buy us time to make that perfect vaccine. And we could also have dedicated production plants. And this is an idea I describe in great detail in the book that has been pushed and promoted for years, but industry doesn't have the funding. Governments don't want to invest in it. And we saw what happened here when it came time to produce product. People ran short of production plants. We couldn't make product quickly enough, even after we had product. We were waiting. We had to ration. All of that could be avoided. We have the technology. We have the know-how. Another push is to make antivirals that work against families in the same idea. Paxlovid was made initially by Pfizer for SARS, not for COVID. Now, it's a mediocre drug, and any of you who have taken it, you well know that it doesn't do what we really want an antiviral to do. It's kept some people from dying. It's kept some people out of the hospital. It's done some good, but we can do a whole lot better. And we know from HIV that if you combine different drugs, you get a lot more wallop against a virus. And we haven't done that with COVID. And we could have on the shelf antivirals that are ready for every family, or for maybe just sarbecoviruses, the same idea for vaccines. We can do the same thing with monoclonal antibodies. We can really rapidly make monoclonal antibodies. And as we saw with COVID, they didn't work when the variants showed up, but they did work. And Donald Trump even may well be alive today because he got early access to one of them. They did work against the virus when the strain perfectly matched. So one question is, can we make monoclonals more quickly? Can we make them cheaper? One way to do this is to make them using mRNA, which the Defense Department has invested in, but then dropped that, and Moderna was doing that and then dropped that. And again, we see things, and I document in my book, that are promising, that could help us in the future, that just don't move forward. There are non-pharmaceutical shields that we can improve. Why do we wear Dr. Kildare-like masks? It's ridiculous. Study after study has shown that surgical masks only offer about 35–40% protection, and this is protection from infection. And N95 masks give you 95% or better protection. They're phenomenal. They're really good, but they're uncomfortable. They're ugly. So this company in Colorado made origami masks, Ergami, and it won a US government competition for making a better mask. And they're beautiful, lightweight. They can be put in the microwave to be cleansed. They were extremely expensive, and the company folded. But it's a great idea. There was a good deal of testing that went on about different masks, and people basically ignored what was found. Bandanas did next to nothing. There really was no reason to wear a bandana other than to signify that you cared about the pandemic or to look cool. They weren't protecting anyone from the virus. As I mentioned, the surgical masks aren't very good. Cloth masks aren't very good. And these NIOSH, the department of the government that tested these masks, has incredibly sophisticated systems to evaluate the value of different masks. We could also have UV light and I go into this in the book in some detail, that kills viruses that could be at airports, and it could be safe for humans. There's a type of UV radiation that doesn't cause harm to humans and does cause harm to viruses. So these are just ideas that we could exploit next time around to better protect ourselves without drugs and vaccines. One of the keys to getting ahead of outbreaks and to preventing them from growing into epidemics and pandemics is surveillance. I visited with people all over the world doing really creative surveillance to try to understand what is out there. A lot of it is incredibly time consuming and difficult. Testing bats is not easy to do. I joined groups testing bats in Thailand, Vietnam, and Brazil. On a good night, you maybe catch and test 50 bats. It's just not a huge sample size. And it's dangerous, and it's smelly, and there are all sorts of things that make it incredibly cumbersome. I went to a hog show in Iowa with the one person in the United States who runs a group testing hogs at hog shows. And I went in Sweden with a group that was trapping gulls because migratory birds move viruses all over the place. And in Brazil, this group, this husband-wife team I went out with, was sucking flies off of trees and pulling mosquitoes out of ponds. All of these types of surveillance yield information that can help us. They don't solve the problem, but the idea for the future is we'd really like to have a weather report. It's good to know that a hurricane or a tornado is coming your way. You can prepare, and that's the point. And now there are next generation surveillance tools that are really exciting. The guy who has in his hand a white little device that looks like a credit card reader, we're at a poultry market in Phnom Penh in Cambodia where they're slaughtering birds, and he's sampling the air for viral genetic material with that little handheld device. He's also put that onto drones and flown it into bat caves, and he's put it onto little remote cars and driven them into chicken farms and things. There's a group in Africa from UC Davis that has worked in Myanmar as well with little fruit-laced sticks that primates sample and chew on, and then they pull that out and pull viruses off that to understand what's infecting them. You can also test primate feces and urine for viruses, which is how we really came to clarity about the origin of the HIV epidemic. The box on the upper right is made by Microsoft. It has a program to analyze mosquitoes, and it uses AI and different techniques when mosquitoes fly into this box to determine what species of mosquitoes are in the area based on their wing flap rates and other morphological things about them. And so then you can understand if you have a type of mosquito that carries chikungunya or dengue show up. These boxes can send you a signal and let you know. And the bottom left is the UCSD wastewater sampling, which people have become familiar with now, but prior to the pandemic, that was really only used for polio. Well, now we can do it for all sorts of things. And on the campus of UCSD, they set up these wastewater samples all over the campus, and they could tell any dorm that was infected, any lab building that was infected. They could pinpoint it by that wastewater. Fire ants in Africa eat dead animals. And so researchers tested the fire ants for the viruses they had after going deep into the forest and eating other animals. And that paper-looking thing is an electrostatic device at a chicken farm that collects dust that has viruses in it, and it was analyzed in the Netherlands for influenza viruses and other pathogens in a chicken farm. All of these things are much easier than what we're doing now. They're safer, and they're creative, and I think promising for getting ahead in the future. We also have to factor in climate change, and I spent time in Germany with a group that went up trees to collect baby eaglets and sample them. And the group in Sweden that I met with on the gulls, they put tags on them that are geotags so they can follow their migratory patterns. The upper photo is in Greenland looking at the permafrost thaw and looking for ancient viruses that may well come up in Greenland in the old middens where people buried their animals and buried people and had their trash. Migratory birds are moving influenza all around the planet all the time. We know that because we see our poultry farms have outbreaks of H5N1, and they are changing their migratory patterns based on climate change. They are the canaries in the mine when it comes to climate change. We see climate change through birds more obviously, more quickly than any other species because of how dependent they are on climate and where they birth, where they spend their winters, where they spend their summers. All of that is being altered now. And that is going to alter our surveillance and the threats to us. And the more we pay attention to what's happening in these migratory birds and also monitor the permafrost thawing, the more opportunity we'll have to get ahead of it. One of the great failures in COVID, and it has been a failure throughout history, is for the rich countries of the world to share their advances with the rest of the world in real time. We are all connected. And I refer in the book to John Steinbeck when he went to the Sea of Cortez and wrote that book, Discovering the Tunicate. The tunicate is a sea sponge that attaches to other tunicates and they share blood, and you can't separate the colony from the individual. And Steinbeck was very fascinated philosophically about that notion of where does the individual begin and the community end? How do you figure that out? We are all connected by viruses, by airplanes. Virologists love to say viruses don't know borders. No, they don't. They do know airplanes. They're really good at using them. And so we tried to come up with a scheme as a globe called COVAX to get the vaccines out. COVAX had some success, but everything was delayed because it relied heavily on a manufacturer in India, the Serum Institute, which is shown here, which makes more childhood vaccines than any company in the world. And when India had an explosion of the Delta variant, the government stopped the company from shipping the vaccine to COVAX as promised. And so much of the world had to wait for a vaccine because we didn't have local production. And so there's a big push now for African countries and countries in Asia to all have vaccine manufacturing capabilities, or to have companies in small countries make huge batches so they can take care of their own, which is natural. I don't think India did something wrong. I think every country wants to take care of its own first. But if they're a small population and they can make tremendous amounts of product, that's one way around in the future this equity issue. And it will be an issue the next time around, that's for certain. It's a very long road from these ideas to products. And the dirty secret in science is most everything fails. We did eradicate smallpox. That vaccine was around for more than 150 years before it happened. The road here where these guys are pulling the motorcycle, I went to an outbreak of Mpox in Kamituga, Congo, and this is how I got there. I had to hike, I had to ride a motorcycle, I had four-wheel drive cars, I had all these people helping. It was incredibly hard to get to this place. It wasn't hard for the virus to get out of that place and go all over the world. The virus from Kamituga now has gone everywhere. And there's a baby in the bottom photo with Mpox. And I'm showing that because I haven't been showing people with disease. The tragedy here is we've had a vaccine for Mpox for years and years. This mother did not have access to it. Her baby didn't have access to it. And we have, Jonas Salk said, the next great breakthrough is to use the knowledge we already have. And so I just want to end on a note that a lot of what we can do that we aren't doing isn't about discovery. It isn't about research and development. It's about using tools that we already have more effectively. And we're just slow to get ahead of this, I think, because our risk benefit analysis is so screwy and because people have amnesia about the last pandemic. Um, and right now, COVID is in an amnesia phase. I think people don't want to think about it. They're traumatized by it, or if they do want to think about it, they want to yell about it. They don't want to really learn from it, and that's what we have to do. I'm deeply grateful to Lewis Library for having me on this day when my book finally is coming out. Colin has been a guiding light in my life for many years, and I can't thank him enough. And the Sloan Foundation funded a portion of this book, which made a lot of the travel possible. Knopf was a phenomenal publisher, and my editor, John Siegel, was absolutely brilliant. And I was welcomed all over the world by very kind people, whether they were affected communities or the doctors or nurses or researchers or politicians. Everywhere I went, people welcomed me with open arms. And I realized working on this book, something I should have realized much earlier, is that everyone everywhere wants to be healthy. And not everyone everywhere wants their children educated for some reason. Not everyone everywhere wants a legal system that works. Not everyone everywhere wants much of anything. But I didn't meet anywhere in the world who didn't want to be healthy and to have their families and loved ones and communities kept healthy and protected from future harm. And I think that's one of the themes of the book too, is that we have a collective interest in building on the hope that does exist to have a better future. And it need not be as bleak as the last time around. That's all I have to say. I'm happy to take questions.
Thanks, John. That was a great talk, and lots of really promising areas of research that you covered very quickly. So you've talked to just about every major infectious disease researcher around the world, and I'm wondering if there's what keeps them awake at night? Is there any sort of common theme that they are really anxious about, be it flu or money or just a waning lack of interest?
Influenza has long been the most frightening thing to the community that tries to get ahead of outbreaks and pandemics. In part because we've had several influenza pandemics that have killed, millions and millions of people. Influenza is a very tough virus to stop the spread of. Our influenza vaccines, are mediocre. They do keep people alive and out of the hospital, but they don't prevent transmission for the most part. And so I think there's a common theme of a worry about influenza. But there's also, in the wake of COVID and the anger a lot of populist governments have toward the restrictions and limits on freedoms that were placed on COVID has led to a backlash against research that is trying to protect us from future harm and to build on what we learned from COVID. So I think a lot of researchers right now are kind of dismayed that they're not receiving the support that they were receiving in 2021 when the panic was high and people were like, we don't want to keep going through this. What can we do better? And governments around the world poured money into research to make a safer world, and that has changed. That's abating.
Well, that leads me into the next question. As you know, the Trump administration has proposed, I think, something like a 40% cut in the National Institutes of Health, which is the primary sponsor of research into infectious diseases in this country. They've dismantled the AID, which is a primary way to get a lot of things out into the rest of the world. they've cut mRNA vaccine research by about, I think the research and grants they've cut is something like $500 million. I know you point out that that's only one avenue for creating vaccines. Just about all of these things are a key to pandemic preparedness. And how much, in your view, are they likely to set back the U.S. ability to respond, U.S. and the world
Yeah.
ability to respond to the next pandemic?
Well,
I
if
know it's
all of
difficult for you as a reporter to give your opinions, but what are your sources telling you?
facts are facts, and you're stating facts. Um, Congress is pushing back. The House and the Senate both have pushed back about cutting the NIH. It remains to be seen what their budget's going to do because we don't have a government at the moment. Um, I think it's deeply alarming that the U.S. government, we have always been the leader around the world and been praised for all we've done. Um, and for our high standards of scrutiny of the products that we do put forward. It's been a model. The FDA has been a model for the world. And the attack on our institutions, the FDA, the NIH, the CDC, aside from putting those people at risk who work there, it, um, there's an absurd factor to it because uh, they are they are the future. That's where it lies. And you can modify and make everything better, and government has its problems. I write critically about government constantly, and I've covered every administration back to Reagan, and I've written critically about every president and every administration back to the Reagan administration. I'm not a shill for any administration. But the US government and its funding of science, which goes back to World War II and Vannevar Bush writing what became a blueprint for the NIH, said, let the government fund basic research and industry will pick the fruit and take things forward. And it's worked really well. It's been a great model. And so dismantling that for ideologic reasons that aren't based on fact uh, is, to me, it's sort of a carpet bombing of the scientific community at a time when we have tools, we can plan miracles, we can do things, but without the support, it's not going to happen because these things aren't attractive to industry yet.
So are there any other organizations that could make up at least some of the losses?
I'm glad you raised that. I mean, for one thing, Europe, Japan, China, Australia, developed countries around the world are putting in a lot of money into these areas. Can they fill the gap left by the United States? I don't think so. I think we have been so far ahead of everyone else in building communities of scientists, having young scientists come up through a system that allowed them to get their ideas funded, even if they were not all that popular. The US was really good at supporting innovation.
No.
And other countries that do put a lot of money into this, my own opinion is they're not as aggressive about innovation. And China does a lot of really great work, but innovation, again and again, we see the United States, and I don't want to shortchange Europe or Japan or any other country or region, but the U.S. has been a leader,
Mm-hmm.
and it comes about from a philosophy. And as I mentioned, the Vannevar Bush, Endless Frontiers was the document he wrote at FDR's behest after World War II to say, look, you made a bomb. How can we do something that's good for people?
Mm-hmm.
The power of science. And it was a really enlightened document that's now 75 years old. And it seems to me like the Trump administration would benefit if they read it.
Great answer. Um, Julie Callahan asked a similar question. She wonders whether you think the private sector will be able to or willing to take up some of the slack that's
Yeah,
been.
I mean, philanthropy will do its part, and the Gates Foundation has been a model for many other philanthropists in terms of global health and has altered the landscape dramatically and invested in a lot of stuff that, um, in my mind, is really helping make a better world. Um, but philanthropy has always built on top of what government does. You can't expect philanthropy to keep universities humming. And the government has been good at that.
Mhm.
And I think that we're asking too much of philanthropies to fill that gap. Also, philanthropy is a very prominent thing in the United States. There are other regions of the world that have wealth that do not have much philanthropy. So maybe look there, you know, and I can point fingers, but it's something that jumps out at me when I look at how much philanthropy pours out of the United States compared to other countries that have very wealthy people who help their own, but don't have an agenda of helping the globe.
Yeah. Uh, AID was probably the principal way to put a lot of the research and the products of research out into the rest of the world. Uh, is the loss of AID as it has been and its incorporation into the State Department, is that likely to be a setback for pandemic preparedness, among other things?
Yeah, I mean, so USAID funded the Predict Surveillance Project, which lasted for 11 years and identified over 100 novel pathogens. A lot of people criticized the project that it was just cataloging what was out there. It wasn't preventing pandemics. Um, but USAID did a lot more than identify 100 viruses. It trained thousands of researchers all over the world how to safely do surveillance. And that in itself is an enormous benefit to all of us. I went to Lesotho and Eswatini in May to see how cutting USAID and the PEPFAR program for HIV/AIDS was having an impact in these two countries, which have the highest HIV prevalence of any countries in the world. And already I could just see the thread coming out of the quilt. Um, these countries have smart people. They do put their own resources into things, but the overnight demolition or wood chipping of USAID, as Elon Musk said, had obvious disastrous consequences.
Hmm.
Uh, it, it's about building programs and phasing them out as you transfer knowledge and you transfer technologies. If you build programs and just get on the plane and pull all your equipment and pull all your people, that knowledge, that equipment, it doesn't transfer. And there is because of the dismantling of USAID, a lot of disease and death that could have been avoided, I believe.
Yep. Julie Callahan makes the same point. She says, as a former USAID employee, I'm devastated by the number of people who have died and will die because the agency has been crushed for all practical purposes. The American public should be aware of the impact.
Yeah, I mean, if you look at HIV/AIDS too, people tend to forget what AIDS looked like. I have been covering this long enough that I remember all too well. It takes a while to go from being healthy on antiretrovirals to stopping the drug and developing symptomatic disease. It will take a year, it will take a couple of years, but if something doesn't change, um, we're going to be seeing AIDS again in ways that will, I think, shock the world.
Hmm.
Because, I used to working for you, Colin, you know this. well, I used to come back from trips where I would see a ward with 200 people dying from AIDS, just like World War II kind of horrific. I don't see that any longer.
Yeah.
The, the drugs are cheap, they're effective, they're safe, and the world has benefited so much from what the US government has done and what USAID has done. And the metrics are there. You can look at it. You can see what happened with that money and what was done. It's not fuzzy. This is hard evidence that what we did worked. And there's an enormous gratitude people have too. I mean, I've worked in, at this point, maybe 60 different countries on the ground. I'm welcomed as an American by people who say, you have done so much to make our lives healthier and better. You know,
Mhm.
of course I haven't done it, but my country has, and I'm proud of that we do that. And so to see that kind of arrogantly and blithely dismissed, it's like, please get on an airplane, go where I've gone, go see
Mhm.
it. Because if you see it with your own eyes and you experience it, you couldn't possibly be doing things the way you're doing them.
Yeah. So I have a sort of a general question about the international coordination of a lot of the things that you're talking about. How is that done? I mean, you described literally hundreds of different projects, and I'm having difficulty seeing how they would fit together and what organization is kind of directing
Yeah,
the money goes and how, uh,
right.
and
So,
what
yeah,
what the new avenues are.
it's a good point. Make a
Presumably, that's WHO, of which the United States is pulling out of.
WHO has played a central role in coordinating many things. Influenza surveillance is coordinated by WHO effectively. Vaccine pre-approvals that countries use instead of their own regulatory bodies is done by WHO. Yeah, the pull-out of WHO is one of several organizations that creates coordination. CEPI, the Coalition for Epidemic Innovations, funds pandemic vaccine research um, and is very targeted in how they're going about coordinating that. Um, Europe has its own coordinations within the European Union and HERA to coordinate European actions. But is there an international body that is coordinating pandemic preparedness? No, there isn't. And there have been attempts, and there have been report after report has called for such a thing. Fortunately, researchers collaborate with people from different countries if their governments allow them to. So, when I go to conferences of virology or immunology, there are 200 countries in the world. There are scientists from 150 of them. I mean, scientists collaborate with scientists from other countries a tremendous amount. It's how that it's how that world works. They live and breathe that, and the training of students is an international exchange and has been for decades. So there's that level of informal coordination. But the NIH had a program to make pan antiviral drugs. The Trump administration has stopped that. It was a coordinated network, international consortia. Same thing is true for pan coronavirus vaccines. Same thing is true for a pan influenza. These are all projects at the NIH that are international in scope and coordinated with hundreds of millions of dollars. And they're either set to end and not be renewed, or they've already received notice that they're dead in the water. So the leadership role that the US was playing internationally has been dramatically affected by
Mm-hmm.
these decisions as of late.
Yeah. One question that I hesitate to ask, the question of the origin of the COVID virus has been one that has really split the scientific community very badly. How important is it to know what the origin of the pandemic was, and what difference would that make to how you deal with it once it starts?
So I think you put your finger on something that is critical to that debate. There's widespread agreement on both sides of this debate that whether it came out of a laboratory or it came from a wet market, that we need to improve laboratory safety and we need to crack down on wet markets trading exotic animals. So what difference would it make in that regard? I don't think much, because I think there's a heightened awareness that both of those present significant threats to humans. The specifics of how the virus went from wherever it originated into humans may never be known, or it may be that we know now more, as some scientists argue, than we know about several other origins that we don't debate. Politics has fueled the debate to a great degree. Passions about things like gain of function research, which there's no evidence that this virus was engineered in a laboratory, but there are people who believe that there are telltale signs that it was engineered. In the book, I focus on how so many of the people who believe in the lab leak, and the President of the United States is included in that camp, believe as though it's a religion. They know. I don't know where this virus came from. I think the evidence to date points to it coming out of the marketplace, most likely from an infected animal to a handler or a seller or a patron at the market. If evidence came up tomorrow that showed strong data that the lab had the virus and leaked it, I would write about that. I don't care. I'm not partisan in that at all. I want to break stories. I'd love to break the lab leak story. I think the lab leak story to date is largely built on speculations, and they're compelling. It's a simple narrative. The missing components of the natural zoonotic transfer, where is that animal? Where is that farm that farmed those animals? Those are great questions. I think China may well have answers that it hasn't shared to some of those questions. China would like the world to believe that the virus didn't originate in China, that it was imported to China on frozen fish. I don't speak with researchers outside of China who have credentials and who I respect, who think that that has any validity. So that's part of the problem. But to get to your central question, do we need to understand the origin of this to better protect ourselves? I don't think it's going to make an enormous difference, because I think we already know that certain types of research require a great deal of regulation and safety precautions, and that exotic animals that people want to eat and buy at these outdoor markets carry exotic things, and they were outlawed in China. They just weren't enforcing their own laws. And we know that now. And we know that China covered up the fact that these animals were for sale at the market. We know that. There's hard evidence that shows that that cover up did occur.
Mm-hmm.
The lab leak theories also get into, I think there are really valid lab leak scenarios that I'm not at all dismissive of. But I think there are some lab leak scenarios that do cross the line into conspiracy theory. I don't think they all should be dismissed as conspiracy theories. Let me underscore that. That's the big complaint from many lab leak proponents, that you dismissed us as conspiracy theorists. No, I'm not dismissing them, but I am dismissing conspiracy theories as conspiracy theories. And
Mm-hmm.
some of the conspiracy theories that have been put forward are eye-popping in the level of complicity in conspiracy people would have to go to for those things to be true.
Mm-hmm.
If you'd like an example, I'll give you one.
Just one general question. Do you have any difficulty talking to Chinese researchers? Are they easy to get hold of? And are they open?
I speak to Chinese researchers a lot. Difficult, yes, there are difficulties in communication. Shizheng Li, who was accused of creating the virus in her laboratory, communicated with me frequently during the pandemic. And in fact, at Science, we published a complete exchange I had with her. We published the whole thing so everyone could see what our exchange was. And you can choose whether to believe her or not. That's up to you as a reader, as a thinker. But the Chinese government makes communication difficult. That's no secret. They have tight control over communication and how journalists interact. I have been to 2 reporting trips in China. The Chinese researchers I met with all over the country on both of the trips were remarkably helpful. Were they as open as a researcher in the United States? No. But researchers in the United States have constraints. And if you work for Pfizer, you're not going to speak openly with me about problems Pfizer's having. If you work for the NIH, you may not speak openly with me about your problems with the director or something. So some of it is just natural that you're going to have restraints in communication, but some of it is the heavy hand of the government in terms of trying to control information. And it can be extremely frustrating trying to find out even simple information from Chinese researchers. And it's not because they don't want to speak. That's not what it is.
Mm-hmm.
There is a fear of punishment that is very real.
Yep.
And at the same time, I'm hoping to go to China soon, and I hope they welcome me. And I look at every government through the lens of it being different from their people. I am not Donald Trump, and I am an American. So
nobody would mistake you for Donald Trump.
thank you.
So we're coming up toward 6 o'clock. I got one final, not a question, but one final comment that's come in. And it's from somebody that we both know. She says it's not a question, but a fan letter. I'm an astro writer, but I've been reading every story in science you've written since before they knew HIV caused AIDS. Your writing is so smart and thorough and utterly believable. That seems to me like a good good note to finish this on.
That's lovely. Whoever that anonymous person is, the check is in the mail. Thank you. That's very kind of you.
This has been a great talk, John. And I really hope the book does well. It really deserves to. So let me pass it back to Rebecca, and she will close it. And John, if you could just stay on the line afterwards for a bit, I'd just like to have a quick chat. So back to you, Rebecca.
All right, thank you. So I just put the information in the chat if you would like to either purchase a copy of the book or borrow a copy of the book through the Delaware Library System. That information is in the chat, and I will send that link out shortly via email. So in the meantime, as is our custom, if you would like to unmute yourselves and applaud and say thank you, feel free to do so. So thank you so much.
Thank you.
Thank you, John.
Thank you.
Thank you very much. Thanks for sticking around.
Thank
It was a real
you.
pleasure.
Thank you very much.
Terrific talk. Terrific.
Thank you very much.
All right, everyone. Thank you so much for joining us.